there so it's
You might have to zoom it in like that. You gotta put it in out.
I think I have a purple one in here too.
Ladies and gentlemen. Don't keep talking. All right, so it doesn't look like this one here is going to pull it on the screen all the way. I don't know what the issue is there, but I can do it from the slides. So we'll do it from here. All right, and we're going to add some things as we go along. This one, there's a few things we're going to be working on as we go through, but really this week we're going to be working on finding the perimeter and area of polygons. Yes. So here is the formative that we have. Just the formula says we're going to be using coordinates to compute perimeters of polygons and areas of triangles and rectangles using the distance formula. First of all, we're going to start off with talking about the Pythagorean theorem. Okay, Pythagorean theorem. So if a triangle is a right triangle, then the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So this is a right triangle. So this says that if you take the leg squared, so if we take one of the legs and square it, and we take the other leg and we square it, and we add those two together, that's going to be equal to the hypotenuse squared. We worked with this a little bit last year in algebra, right? One leg squared plus the other leg squared equals the hypotenuse squared. And again, I see that this is not the best setup for this, but we'll turn it over back and forth as we go through. So now we're talking about the distance formula. And we also used the distance formula last year. So one of the formulas we're going to be used to finding the perimeter around a particular figure in the area is to be able to find the distance between 2 points. And to find the distance between 2 points, we use what we call the distance formula. And we determined whether or not sides are congruent and diagonals are congruent by using this formula, okay? Because you're finding the length of sides between 2 points. And the formula just says that the distance is equal to the square root of the x value from point 2 minus the x value from point 1, that difference squared, plus the y value from point 2 minus the y value from point 1, that difference squared, add those two values together, and then take its square root. Okay. Now, this is kind of redundant because you go, why am I squaring here and then all of a sudden taking its square root? Doesn't really make sense if I square it and then I take its square root. Well, the problem is, in this particular point value here, if we don't square it, we could wind up with a negative number, right? So if I have 3 minus 5 right here, I'm going to wind up with a negative number. And if I wind up with a negative number, that can't represent distance, because distance is not measured in negative numbers. So what we do is we actually wind up squaring in the inside, and then we take the square root at the end, and it's kind of reversing the process. But when doing that, you don't wind up with any negative numbers. Let's go to the next one. All right, so essential understanding, you can find the area of a parallelogram or a triangle when you know the length of its base and its height. A parallelogram with the same base and height as a rectangle has the same area as a rectangle. So the area of a rectangle is the product of its base and its height. So area, length times width, right? Or base times height. We all know that. perimeter is the distance around, right? That's what we're talking about when we talk about perimeter, just the distance around. Who in here plays video games? Just one person, two people? Okay, okay, there we go. There's a few more closet video players. No, because you don't want to come out.
My parents limit my playtime.
They don't like to play time. All right. So when you talk about those video games and you're playing, like, I don't know, what's the name of one of the Army ones that they do?
Halo.
What is it?
Halo.
Battlefield 1.
A what?
Halo.
Halo. All right.
Wait, can we?
Sorry. So if we're talking about Halo and you're working with the game and it says you guard the perimeter, right? They might have somebody on the game saying you guard the perimeter or whatever. They're talking about the distance around, right? All the distance around. That's the perimeter. That's your job, right? Okay. So when we talk about the area of a parallelogram, now this isn't necessarily a rectangle, right? This isn't a rectangle. This is a parallelogram, just meaning that it has four sides that are parallel, or two opposite sides that are parallel, I should say. And of course those opposite sides are congruent. So the area of a parallelogram is a product of a base and the corresponding height. So it has the same formula as the area of a rectangle. The only difference is, to find the height, you've got to find the distance from this vertex to the base, because the height isn't this. This would be called a slant height because it's slanted, right? Slanted is not straight up and down. This would be the height where it's straight up and down. So a base of a parallelogram can be any one of its sides, the corresponding altitude, and that's what we call this right here. We call that an altitude. The corresponding altitude is a segment perpendicular to the line containing that base drawn from the opposite side, or from the side opposite the base, excuse me, and the height is the length of the altitude itself. So here we have a triangle, right? You try to find the area of a triangle. Now the area for a triangle is this. Here's the formula for finding the area of a triangle. It is the area equals 1/2 times the base times the height. Base times height. Now you notice these are lowercase letters. These are not uppercase letters. Make sure you use lowercase letters when you are writing it down, because uppercase B stands for something other than base. It stands for area of the base. So when you have a capital B here, it's talking about the area of the base, not the length of the base. So the area of a triangle is half the product of the base and the corresponding height. Now, if this triangle was turned sideways, the other way, then this would be the base. If this triangle was laying on this, then this would be the base. So it's all about positioning when you're talking about the base of a triangle. All three sides could be the base. Just depends on how you look at the triangle. Just turn it around. If it's easier to do it one way, then call the other side the base, call the other side the length, okay? Or the height. A base of a triangle can be any of its sides. The corresponding height is the length of the altitude to the line containing the base. So from the vertex straight up and down, perpendicular to the base. Okay. All right, so now we're going to be able to do a little bit of work here. We'll have to just stand here and stare at this particular item. So sometimes when we talk about the area of a figure on a graph, we can actually count the squares. So sometimes we can count the squares. So if we count these squares, go ahead and count your squares. So if you count the width down here at the base, it is 1, 2, 3, 4, 5, 6, 7, 8 spaces, right? So that would be 8 units. The height would be 1, 2, 3, 4, 5, 6, 7. 7 units. And if I'm going to find the area of this figure, remember the area of a triangle is 1/2 times the base times the height. 1/2 times the base times the height. Now, remember I said that earlier it depends on which side is easier for you to use for the base, right? So if I were to turn this way, I have 7 units across. Well, the formula says I take 1/2 times the base times the height. So that means I have to take 1/2 of 7 times 8. Is that easy to do? Because what's 1/2 of 7? 3.5. 3.5. So 3.5 is half of 7. So that means I'm going to have to take 3.5 times 8. And I may need to use my pen and pencil to do that. But if we turn it this way, and we have this as our base, and we take 1/2 of the base times the height, now we just have 4 times 7. Because half of 8 is 4. 4 times 7 is 28. So this would be 28 square units. So 1/2 times 8 times 7, that would be the area, and that means the area is equal to 28 square units. Sorry, 28 square units, okay? Square units. Or 28 units squared, okay? Or 28 units squared, okay? Anytime you're dealing with area, you're talking about square units. Okay, keep that in mind. Anytime you're dealing with area, you're talking about square units. Perimeter is just however many you have. You're just adding them up total. But area is going to be in square units. All right, so here's an example of finding the area and perimeter of this particular rectangle. Now this one's going to be a little different. Because if you look at this one, I can't count the units coming across here. I can't count the units coming across here. Or here, or here. I don't know how many spaces those are because they're not vertical or horizontal. When they're not vertical or horizontal, I can't count the squares. I've got to use what we call the distance formula in order to do this. So remember, the distance formula is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. You got to take the square root of all that. Now, for the sake of time, what I'd like us to do, we're going to break up into 4 groups. Let's see. Okay. So groups of 4. So if you 3 and Caroline, you 3 and you, I want you to find the distance between C and B. So rather than all of us do all of them, you guys just find the distance between C and B. Okay, you 4. If you 2 and you 2 can get together, I want you to find the distance of AB. Okay, so find the distance of AB, you 4. Okay, and then if you guys and Caden, if you wouldn't mind joining that group, I want you to find the distance on AD, so between A and D. And the Bay, I'll let you join the group over there of 4, so your group is going to contain 5. And I want you guys to find the distance of DC. Okay? So go ahead for a few minutes and see if you can find that distance.
really good teamwork over there.
Five, three, two, seven, eight. Gosh darn it. What did you do here, so?
She's on the front ankle.
Good job.
According to other days.
0, 7,
No, it's got it.
0, 6.
Square root.
And once you find the square root of the number, just leave it in that format. Don't put it in a decimal or anything like that right now. We're just gonna find the square root of the number.
The answer's right there.
Whatever that is, that's our answer. What's that?
You can do that.
85. Oh, that's not playing games.
See?
What did you? I guarantee you it's wrong. What did you do? What did you do? I think I did this wrong. Let me see. I think I was final line, so I was 9.219544457. Where did you go?
Oh, boy.
Wow, that's weird.
Oh, my God.
Well, for X, it'd be, 3, I take this exact equation, I got it 7, yeah, 7, and then that goes to 49.
What's the help your mom?
Wait.
Oh my God, you're freaking weird.
What is it?
My dad's been here 4 weeks. My mom does it too. That's all I'm learning, right?
Yes, sir.
Okay, so I have a question. After we get the big answer, do we have to square root that too, or no?
Right now, no.
I was just wondering.
Yeah.
Okay, then.
We're just looking for that answer.
Should be. You don't, you probably did it wrong, Carrie.
All right, so once you find your answers, okay, once you guys find your answers, compare your answers with each other. Make sure you all have the same values.
And you're not supposed to square root it.
Yeah, you don't have to square root the final answer.
Wait,
You don't?
so,
No.
after
Okay,
you get
but I
that,
should- But he did.
Okay. But I said you didn't have to.
I know. You're not supposed to be so positive.
You know the final numbers you get before you take the square root? I said you didn't have to do that.
Look,
I got both
you know,
answers.
it's the
Okay.
final answer.
It's okay if you have both.
I don't know what answer you want, but I got it.
All right, good.
I know.
So, go back to your seats. We're going to find out from the first four what their value was. So this would have been CB, right? You guys found the distance between C and B? So what'd you guys get?
square root of 50.
Okay. Does everybody agree? Everybody got that? Okay. Okay. So the next one was AB. What'd you guys get for AB?
Square root of 85.
Okay, is that what everybody agreed on?
Yeah.
You guys got square root of 85? Okay.
Of course, good.
What about AD? This other group, what'd you get for AD?
That.
Courtney?
They told me it was wrong.
Okay, what was it?
I got the square root of negative 41.
You're very close. You're very close.
I got positive.
Yeah, it'd just be a positive. You can't take the square root of a negative number. Remember when I said the reason that we have the formula written the way it is so you don't wind up with negative numbers? So you squared correctly, but the problem is anytime you square a number, you always get a positive number. You never get a negative number. So good. So square root of 41. And the last one for CD, last group there, you got
12.
square root of 12.
Yeah. Yeah, square root from 100.
Everybody got square root of 12? Yeah.
Is it wrong? It's wrong.
I didn't get that, but we'll see why.
What'd
Okay?
you get?
So let's take a look at it. So, well, let's do it on screen. That doesn't mean I'm right and you're wrong. All it means is that we should take a second look at it and double check.
Yay!
Okay. So here are the 2 points. A is the point -4, 9, and B is the point, excuse me, not B. D is the point -8, 4.
We did D and C.
What did you do, D and C?
Yeah.
Well, let's start over.
Great, great.
So D was the point -8, 4, and C was the point -2, -2. So the formula says that we're going to take the x value from point 2, subtract the x value from point 1 and square that. Take the y value from point 2, whoops, subtract the y value from point 1 and square that, and then take its square root if you need to. Okay. So we're going to call this point 2, this point 1. I could have done it the other way around. Should give us the same result. But this means we're going to have -2 minus a -8 squared plus a -2 minus 4 squared. Well, -2 minus a -8 is +6. So now we have 6 squared, and I know where you got your 12 now. And you have -2 minus 4, that's -6 squared, and you just added those two together, right? Yeah. The problem is, this is one more step you had to take, because this is 6 squared, and this is -6 squared, okay? So this is actually the square root of 36 plus 36, which is the square root of 72. 72. So on this particular one, we had CB. So CB wound up being the square root of 50. AB wound up being the square root of 85. AD wound up being the square root of 41. And this one wound up being the square root of 72. Now, looking at that right now, would this be considered a rectangle?
No. There has to be two incongruent sides on the
Okay.
triangle.
So this would not be a rectangle. This would be probably, possibly, I don't want to say for sure, but it's possibly, well, wouldn't even be a parallelogram, would it? Because on a parallelogram, the opposite sides are congruent as well. Okay? So more than likely, these two sides here are not parallel as
It's a
well.
quadrilateral.
Pardon me?
It's a quadrilateral.
It's definitely a quadrilateral, okay? But it's not a parallelogram. It's not a rectangle. Okay. All right. All right, good. Distance formula. All right, so this is 3 vertices. Says draw the polygon with the given vertices, find the perimeter and the area of the polygon. So if you could, on your paper, label these 3 vertices on here and do just that. Find the area and the perimeter of this. Well, actually, let's do it together on this, okay? So we have the first point, -2, -3. So F is -2, -1, 2, 3. So this would be F. G would be -2, +3, 1, 2, 3. So it would be this one. That's G. And then the other one would be 2 zeros. 1, 2, 0, and this is H. And I'm going to go back and I'm going to label these points on the graph. So F is the point -2, -3. H is the point 2, 0. And then G is the point -2, 3. Okay, we labeling our figure?
Yes.
We drawing our figure? I'm looking at somebody very specific. Yes? Do you have a pencil? Yeah. All right.
Yeah, I did it.
Okay, good. So if we're looking for the perimeter, we need to know the distance from here to here. We need to know the distance from here to here. And we need to know the distance from here to here.
Don't we already know that one?
This one we can figure out pretty easy, right? Because all we have to do is count the squares. So this one, all we have to do is count the squares on it. But these two are diagonals, and we need to use the distance formula to find the distance between those two. So we know this one is 1, 2, 3, 4, 5, 6 units. So this one is 6 units. So use the distance formula, same formula used together with your partners a while ago, and find the distance between those two sets of vertices. Again, if you don't remember what that formula is, it is the x value from point 2 minus the x value from point 1 squared plus the y value from point 2 minus the y value from point 1 squared. And again, it doesn't matter which point you call point 2, which one you call point 1, as long as you do the same for the x's as you do for the y's.